everyone. This is Mike Mcdonough, Senior Consultant with Stone Door Group, and I'll be basically going through the exercise here. So, for whatever reason, you didn't want to do the hands-on part, type on the keyboard yourself. I'm going to be, showing, going through the steps and, demonstrating all the lab exercises so that you can see it. And, certainly I think this makes a lot of sense if you're busy and or whatever have you. It's a good opportunity to to learn, see this material, without actually having to, do the hands-on part. Certainly, this exercise, if you don't have time to do it now, you can watch, this and, at a later time, go through the lab exercise on your own as well. So that's another option out there. So let me share my screen and we'll get started. All right. So hopefully this is coming through okay. So Stone Door Group, Red Hat OpenShift Technical Workshop. As CJ mentioned, this is an introduction to OpenShift. OpenShift is and when we look at the underlying technologies, Kubernetes, it is a huge and vibrant ecosystem that's rapidly developing. So, one thing that's really interesting about working in the OpenShift space is just, you never know everything about OpenShift and all the add-on components that people are building for the platform, for Kubernetes, for OpenShift itself. So there's, the pace of development is really pretty outstanding compared to how things used to be in the IT world. So, we'll go through this. Please ask questions, if you have any. And certainly I'll preface this that with I personally do not know everything about OpenShift. It's always a learning opportunity. Pretty much any time I set out doing something on the OpenShift platform, there's always an opportunity to do something a little bit differently. There's different ways of accomplishing goals or accomplishing a certain objective, and certainly there's lots of new technologies out there to dig in and take advantage of. So first of all, this lab is being done on the on the IBM cloud. So if you signed up for this webinar, we went ahead and sent you a invite to an IBM cloud account. This account happens to be actually in my name, so you'll see invited to Michael Mcdonough's IBM cloud account. Just kind of how we ended up setting up the account this time. So if you want to go through that, you would click the Join Now button. Just enter in some basic information, set your password, and then you would have access to the IBM cloud account. Now, the reason we do this is that this OpenShift instance is, of course, deployed on the IBM cloud. And the way, one of the advantages of using IBM's OpenShift offering is that it's tied into the IBM cloud IAM service. So what you'll see is that to log into this OpenShift cluster, you do that using your IBM cloud credentials. So in the document here, this is just going ahead and getting started. You log in, put your email address in, of course. I think everyone knows that. And then, okay, so now we can transition to, to a live demo. So here's the IBM Cloud console. Everyone's set up basically with developer permissions. And we actually, in addition to standard developer permissions, we also gave everyone the ability to view resources at a platform level. And what this allows you to do is to actually kind of see the cluster, gives you some more buttons to click around on. In a production situation, we could actually tighten this up and allow a developer to log into to OpenShift, but not really even have this level of access to the IBM console per se. But we wanted to, we wanted everyone to see the IBM Cloud offering itself, right? And see some of the things that it has to offer. So once you're logged in, there's a couple ways to define the cluster. And then actually, let me go back here on the first page, the dashboard page, resource summary. There'll be a link to clusters, and there's a, if you have additional resources deployed on the IBM cloud, they would show up here. You can also click the expand this menu, go to OpenShift, and go Overview. So this will show us our OpenShift clusters. Click Clusters. And this will show us the clusters that we have deployed on this cloud. Now, in this case, we have one cluster called OpenShift Demo 01. State is normal, and it's deployed to IBM's Dallas facility. It's also showing us the number of worker nodes that we have and some version information. So we can click on that. to open up the cluster detail page. And of course, while you're trying to show, trying to demo, goes a little, sometimes my internet connection's been a little flaky the past couple days, so you'll have to excuse there's a delay at times. So here we go. So we've got, this is the IBM Cloud console that allows us to manage, kind of gives us some visibility into the cluster, the state of the cluster, and it gives us an easy way to access access that cluster. Cluster ID gives us the status information, shows us the worker nodes, shows us the status of those worker nodes. And depending on, if you're logged in with the correct credentials, if you want to expand the size of your cluster, you can do it from this screen. There's an add button here that you could add a node. Now I'm logged in with developer permissions, so if I click this, what's going to end up showing an error. But with the correct IAM permissions, admin type credentials, you could add nodes to the cluster. Actually, I did this yesterday to this cluster. We were running with 3 nodes before today's event, and so just to make sure we had enough CPU and RAM resources for people that wanted to do the hands-on lab, I expanded the size of the cluster, actually using the command line tools. So IBM Cloud Platform has a CLI interface called that provides a command called, appropriately enough, IBM Cloud, and the IBM Cloud command really gives you, kind of full control over your IBM Cloud resources, including this cluster. So I was able to expand the size of the cluster using the command. There's a sub command called IBM Cloud OC, which is basically OC for OpenShift. You'll see OC is the name of the command that we use, the kind of the native OpenShift binary command that we use. So this allows us to, if we go up here, so cluster management workers, worker pools, we can add a pool of workers, we can add additional workers, to the size of our cluster, do that command line or through the web user interface. And, that's nice. If we were comparing deploying OpenShift on IBM Cloud versus other platforms, what you'll see is that there are installers that with OpenShift 4 that allows you to deploy an OpenShift cluster on AWS or Google or Azure. And there's a command line Terraform driven installer, which is pretty nice. But what you don't have is the level of integration between that OpenShift cluster and the cloud platform. It's kind of more of the installer takes advantage of the cloud platform native APIs for deploying resources, which, with what they call installer provision infrastructure deployment, it makes it really quick, easy to deploy a cluster, but you don't get the level of visibility and management that you do versus the IBM Cloud's more integrated approach to deploying OpenShift. So once we have our OpenShift cluster up and running, go back to our overview page. The reason one of the reasons coming to this page is to access the cluster. So, if I have just fired up a new cluster, how do I access that cluster? So one thing you want to do is install the command line tools. And that on a Linux system is simply a matter of downloading the idt-installer file. You pipe that to bash, and that actually installs the IBM Cloud, this IBM Cloud command. Now, one note is that you actually want to rerun this curl command for each user that is going to be using the IBM Cloud command, at the CLI level. So what I did is we ran this once as root to install the binaries, and then run it again as each regular user. And what that set, when you run it as a regular user, what that does is sets up the plugins. Let's see here. Oops, and of course, let me get the right command. Oops. So we want to do some help if we don't remember. And we want to do IBM Cloud. Oh. That's not right. All right, well, I'll figure that I'll come back to the plugin piece in just a moment. So it's kind of going off on a tangent anyway. So to come back, install the command line tools, do it as root user, and then run it again as a regular user. And it's simply a matter of running this curl command. And that's why I don't remember the CLI version. There's a command to check the what plugins are installed. So if you don't do that as a regular user, what you'll find is the IBM Cloud command's available, but you don't have the OC command, and some of these commands to manage the cluster don't work as a regular user. So if you run into that situation, just rerun this command at the top here as your normal user, and that'll set all the plugins up for you. So once you've done that, you know, and of course, certainly you don't, you know, the CLI is optional. You can do everything through the web UI as well. You know, it really depends, certainly preferences. I think most developers nowadays and, you know, admins though, appreciate having the CLI tools available. So the next thing is, you know, how do I access the web console? Do this by clicking the blue OpenShift web console button. And that's going to give us some information, basically allow us to access the web console. And let's see here. What are we doing? Okay, well, I'm actually, here we go. So I opened it up tab wise. So what that does is actually opens up a new tab with the OpenShift control plane. And this should, one moment here. Yeah. All right, give this just a minute to see what's going on here. Maybe I might be having some technical difficulties. Oh, there we go. All right, so now we've got the OpenShift web console open, so it opens in a new tab. There's a couple different ways, you know, so this is allowing us to access the web console itself. If you want to actually access the cluster at the command line, which certainly is something we would want to do for this exercise, once you have the, once you're logged into the cluster, and one of the nice things is it doesn't prompt you, you know, once I've logged into the IBM Cloud, the OpenShift cluster is integrated with IBM Cloud's IAM system, so I'm already logged in to OpenShift, so you don't have to log in again. And then to log in at the command, to set up the command line, access to the cluster, what I did here, click the drop down top right, click copy login command, and then click display token. This token, you'll need this for accessing the cluster. You know, the first thing you'll want to do so that the OC command, which is the command we use to manage OpenShift, the OC is the native binary command line interface for OpenShift. You'll want to copy this and come over here, just clear that, paste it into our console. All right, so now I'm logged in. So I'm logged into the cluster. I've access to the projects. I do, you know, OC git projects, make sure that returns a list of projects. Okay, see all the projects. So now I'm logged into the cluster. I've got credentials and I can access the cluster via the web UI or the CLI. The lab exercise is set up kind of as a mixture of both. So there's options as you get to the lab exercise to do things at the command line. Or, you know, you could certainly do the OpenShift web UI is full featured. I would say, you know, or, you know, maybe not every feature. There's some things the command line, you know, you can't do everything in the web UI, but most of it you can do via the web UI. They've really done a good job with the web UI, making it usable, you know, both for administration, you know, monitoring and for developer type activities. So normally when you're a developer and you log into an OpenShift console, you typically not see these projects that start with OpenShift. The reason I'm seeing these projects today is that it goes back to the IAM setup in IBM Cloud, and because we gave everyone that extra bit of access to be able to see infrastructure resources. So what that's doing is, one, it's giving the ability to see the infrastructure resources in the IBM Cloud web user interface or at the command line with IBM Cloud Command, and it also carries over to OpenShift. It allows us to see kind of more under the covers with OpenShift. However, you know, if we look at what we can actually do, so if we do an OC git you know, let's say git pods, what you'll see, yeah, let's see here, let's see git. Yeah, so I've got some visibility. You know, if you do OC git secrets, yeah, it gives us error message because I don't have, that's forbidden because I'm logged in as a developer user. I don't have full admin rights. So the way the IAM system, the integration between IAM Cloud and OpenShift, and this is all documented on IBM's documentation, but there's, you know, basically I have view access, and so I can see some things about the cluster, but I'm not a full administrator, and so I can't see things like secrets, for example, in a project that I don't own. All right. So let's go back to the lab exercise and let's see, or leave it there, dashboard. What we want is this. Okay, so back to the lab exercise. So log into the cluster, verify your access, log into the console, which is what I just did. The Bastion host. So I'm doing this all, we have a system set up. If we do host name, called bastion01.demo1.pd.stonebuilder.io. It's a little bit long, but this host we have set up so that to give everyone a consistent environment to do these labs. So you know, part of the lab exercise is to log into the system, you know, from there you can run the IBM Cloud command, you can run the OC command, and basically do all the steps in the lab at the command line level from this host. If you're doing this lab yourself and in your own environment, you certainly can, you know, you basically just want a Linux system, Red Hat Enterprise Linux, Fedora, whatever have you, and you'll want the OC command, that basically the OpenShift binaries installed, download and install that. And then if you're using the IBM Cloud, you'd also install the IBM Cloud CLI with the curl command that we looked at just a moment ago. So I'm already logged in. I'm already logged into the cluster, which is this OC login command. And if we come back over here and do OC who am I? I'm logged in as Mcdonough dev1 at stonedoorgroup.com, and already showed we can get projects. So let's start in with the lab exercise. And actually give me just one moment, and then we'll actually get into the deployment exercise. Set up here. All right, let's see here. So, okay, so without further ado, so create a new project for your application. So this lab exercise is going to walk us through, you know, some basic deployment steps, and we're going to build up the complexity. We're going to start with, you know, kind of basic application deployment, and then we're going to build up to a certain, actually deploying an application that in a service mesh configuration with the service mesh tools tool set that goes along with that to give us visibility into our services. And allow us to monitor what our application's doing, the communication between the various components in our application stack. So we're going to kind of start off simple and work our way up in complexity. So the first thing we want to do is create a project. So we do that with the OC new project command, OC new project, and just to make sure that we're not all creating projects with the same exact name, we're going to preface that with our initials. Now, when we create these projects, the project in OpenShift is equivalent to a namespace in Kubernetes. A project is actually kind of under the covers, is built on top of namespace, Kubernetes namespaces. It's kind of like a namespace plus, kind of like a, you know, what you say, a namespace on steroids. But it is under the covers. There isn't, when we create a project, it also creates a Kubernetes namespace. Along with the OpenShift bits that make up a project object. So OpenShift new dash project, create that and return. All right, now I can do an OC git projects. Let me just to keep things a little cleaner. There's our new project. And if I do an OC project command, it should show that I'm using that when OpenShift, when you create a new project, it automatically changes your context to be that project. So deploy the application. This time we're going to use the console to deploy the application. So come back over here. Let's find our project. JM, Java template. All right, so here's our project that we just created. And if we go back to our instructions here, what we're going to want to do is we're going to want to deploy an application into that project. All right, so overview, the project details, and of course, overview. There's our project. If you say, what is a project? So this is the YAML that basically makes up the project. Definition, there's really not, in this case, there's not a huge amount to this, but it does show us some information, who owns this project, who's the requester of this. And one thing you would see is if developer A creates a project and developer B is on the system, one thing that by default, I won't be able to access the other developer's projects and vice versa. We'd have to set up some role bindings and give the developers access to this project, probably create a group, create a role binding, and add the developers to this particular project. So coming back to our lab exercise here, we want to deploy a template. And what am I doing here? And where's the catalog gone for me? Well, of course, I'm missing the one button that I need. Truthfully, I usually do, personally, I do more things by the command line, so I'm not as familiar with the web user interface. Use it, but I just don't use it consistently, I guess I would say. Not for deployments, at least. Typically, deployments on OpenShift are done via templates. Basically, application configuration and deployment information is defined in YAML configure files ahead of time, and those YAML files are used to deploy your application. And of course, then they move things around on us as well from version to version. So give me just one moment. And oh, I know what. There we go. Okay, so I know I was missing something, going crazy today. So the OpenShift web user interface has two views. It has a developer view and an administrator view. I was in the administrator view. If you see here, developer administrator. And that's why I didn't have the button that I was looking for, because it wasn't there. I needed to switch over to the developer view. So once in the developer view, we can go to the catalog, and we go back to our lab instructions here. It's asking us to deploy the Open JDK. So we'll go ahead and do that. So Red Hat Open JDK. We can create an application, try the sample. And let's see here. One of the things that the differences between Kubernetes and OpenShift is that Kubernetes, the default way of defining a container, an application, is via what's called a deployment object. And OpenShift has deployments, but also has what we call a deployment config. And a deployment config is kind of a superset of the deployment concept. What you'll see is a mix of deployments and deployment config type scenarios with OpenShift. So you're certainly, if you're coming from a Kubernetes app background, or you have an application that's native to, just to Kubernetes, that's typically going to be deployed via deployment object. On the other hand, if you have an application that's been deployed, developed, or at least the template for deploying the app is really on OpenShift, you're more likely to find a deployment configuration. There's pros and cons to either. Deployment configs are OpenShift centric, so deployments are more portable, but deployment configs, if you're using OpenShift, do provide some, a few advantages if you want to go that route. If you're not worried about the portability aspect. All right, so sample workload, so create application, try sample. In this case, I think we'll just stick with the default of deployment. And what we'll need to do here, 1 second, I think I'm missing the bottom of my browser window. Create the application. What am I missing here? Try sample, where is the button? Yeah, still missing. There we go. There's the create button. Couldn't quite see it. All right, so click create, and that's going to deploy our sample application. In this case, a Java application. Give us, basically kind of prove out, show us that, that our account is working correctly, and that we're capable of, basically that everything's set up. So if we come back here, go to workloads, go to pods, Java, make sure our project is set to Java template. Notice now we have Java build. This is running, and that should deploy our application, assuming I clicked all the buttons correctly, which of course is, let me switch this, give me 1 second here. Let's do that like that. That's a little easier. All right, so left menu, pod name Java 1 build. Let's see, take a look at the logs. All right, so this via the logs option. So a pod, this is an instance of our application. So what OpenShift did behind the scenes is, one, it pulled the container image that was specified in this particular template. It then instantiated a container using that image, and because if we looked into the details of that template, it went ahead and in this case started a Java application. And so we could look at, first of all, what's the definition of our pod, right? So we can look at the YAML side of things here. This definition is created based on the template that we picked earlier. This copy of the YAML is specific to this pod. If we deploy another copy, it's going using the same template. Guess it's going to be very similar, but things like ID values would change, right? There's some things that are very specific to this pod, like a UUID, creation timestamps, that sort of thing. But this is all based on the template that we picked in the previous step. We can see if there's environmental variables. Sometimes when you're deploying an application, it's actually very common to, you have to look at how can we configure this particular instance of an application. One way to do that is by setting environment variables that the application can then read. So we can basically pass in configuration information to the application via environment variables. Look at our logs. So that's basically the result. Everything that was output to the console for that particular container will be available here. Particular events. So this shows us the platform level events associated with this particular, in this case, we're looking at a pod. So things like, pulling the image, creating the container, starting the container, right? All this will show. And if there's any problems, of course, they would, at a platform level, with this pod, they would show up here. Terminal, we can also actually access the terminal. So if we do, this is actually a shell session into the terminal. Notice I'm running as the user JBoss, GID root. If I do a ps-ef, we should see our Java application. And if we do an ls of root, this is actually a shell terminal inside, basically inside that container running on the cluster. So let's see here, workshift pods. Another thing is, when we deploy an application, you want to be able to access that application. So if we come back over here and do an OC called get routes. So with OpenShift, the default way of exposing an application outside the cluster is via what's called a route. And the route mechanism, there's other ways to do it with ingress. For example, there's other kind of more Kubernetes mechanisms, but routes is typically how it's done with OpenShift, at least especially by default. Routes are an OpenShift specific kind of implementation, but all the Kubernetes mechanisms are available as well. So with routes, the route exposes a service. So if you look at kind of bottom up, we deployed a container, the container was based on an image that we specified. We started the container, started the application inside that container. One of the other things that the template did is create what we call a service. So the service here named Java, this service exposes the application basically within the cluster. So it creates a cluster IP ports. So this exposes that container and makes it reachable inside the cluster. Now, that's great. In a lot of applications, that's kind of where you would stop. However, if you're starting an application that's needs to be accessed by users outside the cluster, let's say people accessing your website or your web application, we do that via route object. So we take the route. This is actually a URL. So copy that, come over to our browser window, paste that in. And hello world. So this is our Java application that I just deployed, and it's just a basic hello world type application. All right. Give me any questions. Give me one moment. It's hard to watch the chat session at the same time. So give me 1 second here to check the chat and get a quick drink, and we'll continue. Give me one moment, please. Okay, all right, great. I wanted to make sure if anyone had any questions that I was able to see those questions pop up. So we've got a basic, Java application, just, a test application deployed. What do we do next? So, one of the things is to look at, kind of look into some more of the details. We just talked about services. We talked about routes. So service exposes the container within the cluster, makes that containers, that process available via a specific IP address and port. The other thing the service does, if your application if you have multiple containers deployed for the same application, a service basically provides a load balancing mechanism. So, if we had, for example, multiple replicas of this Java application deployed, the service is going to help route the traffic and help us route those requests to, container A and container B, for example, if we had 2 copies of it running. Routes expose that an application or a service, HTTP, HTTPS, to the outside world. There's other options if you're deploying something, if you need to expose something besides HTTP or HTTPS. There's ways to expose, basically at the port level. There's 2 or 3, 4 different options for exposing your application. But routes on OpenShift are kind of, especially for web, typical HTTP, HTTPS type applications are the most straightforward way. When you create a route, it's going to create a URL. This URL here, there are ways you can customize this URL. Certainly, right, this is not something you'd want to, give to your end users. So typically, there's ways to customize this URL, shorten it down, and in most cases, in a production application, you'd create a C name that points to this to shorten it up and make it pretty for your actual external users. So if we run the OC command, again, OC is the binary, basically the OpenShift CLI binary command. You can run the git all command, oops, not get al, get all. That's going to show us all of the OpenShift objects within the current project. And so if we look here, let me clean this up. OC get all, so this shows us our pods. Notice that there are 2 pods listed, only one of which is running. So when we deployed this application initially, part of that definition was included what they call a build config. And so, that build step actually downloaded code from the internet, downloaded the container image to code from a Git repo. When I click try sample, that actually input a GitHub URL or Git repo. So it downloaded that code, and guess it combined those two together and built an image that is actually deployable on this platform on our cluster. So the build pod ran, completed. Once it was done, it spun up an actual copy of our application that contained the container image plus our code from the Git repo, created a service. In this case, we were using the default deployment type object, created a replica set. So the replica set allows us to control how many copies of our container are running at a time, and kind of so on. Those are build config, the build object, image stream, that's the image that was pulled down, and then we have our route, which is the way we expose our service and thus the application to the internet. Or to external users. There are other objects out there that are, when you run OC get all, it's slightly misleading. It doesn't actually display every object in the namespace, but it displays the common objects. There are other objects like secrets, for example, that are not in this default list that are created. And there's some things like config map secrets, volumes when you get into storage. So there's some, just be aware that OC get all, there's some, it displays the common objects, but not everything. And that comes into play when you're trying to delete something, or, you're kind of getting more hands-on with controlling your application. You'll want to remember that, because that's something that sometimes you'll have to go in and, for example, if I was trying to delete this application, if I said OC delete all, it wouldn't actually delete all the secrets for these two secrets, for example. But it would delete all these objects listed in the first command. All right, so what are the things we can do? And here's some of the other ones. So service accounts, events. So service accounts. And there's ways, if you look at OpenShift, there's ways to abbreviate objects in OpenShift. So as you work with this, the command line, typing out service accounts, kind of long, right? There's more than 10 characters there. So you can type, instead of that, if you can abbreviate it down to SA, instead of typing, OC get service, I can also shorten that down to SVC, pods. Instead of pods, you do PO for pods. So there's these abbreviations, and you will want to learn those as you work with OpenShift at the command line, because it just, saves some typing and makes things go a bit quicker. So coming back to the lab here, we've looked at that. So we can look at more details. So this is kind of just listing things. How do we actually look at the details? So one thing we can do is use the describe command. We have to tell it what type of object and then the name of that object. So in this case, OC describe pod, and this could be plural or singular, and then the name of that pod. And if we look at that, let's do that. It's a little bit long, so let's type it to less. So this gives us, basically detailed information about our pod that's running. It shows us the containers that are within that pod. You can, this will come up later on in the lab, but you can deploy multiple containers within the same pod. And this is actually leveraged by the lab exercise and service mesh architecture. So pods are basically give us a level of isolation between our various containers. So if you have pod A and pod B, by default, they're isolated from one another. If you deploy two containers, each with a separate pod, and you want them to communicate with each other, you're going to have to allow that explicitly. On the other hand, if you have two containers that need to communicate basically by default, that they're need to be closely linked together, I can deploy two containers within the same pod, and that's going to allow them to share networking resources and as well as storage and some other things, kind of by default. So containers, if you have an application that's split into multiple containers, and then you have multiple containers that need to operate closely together, deploying multiple containers within the same pod is an option that you want to look at. And it's very common with logging or anytime kind of where you want to integrate with containers, monitoring, logging tools, that sort of thing. It's common to have that multiple containers within the same pod. Other things, it shows us our ports that are exposed, shows us the events associated with this pod. If we come back to our web user interface, come back over here, pod details. Guess what? This is really the same thing I'm seeing in the web user interface. Here's our events. These are the same events. I can see them through the web user interface, or we can see them at the command line. So build configs, we'll look at kind of one more piece here. So looking at the build config, this build config, it's a little easier if we clear it first. So this build config namespace, this is the project that we're working in. Labels are used. Labels are one kind of basically arbitrary key value pairs that you can associate with a particular object in OpenShift, and they're used extensively. You could use them for your own purposes. You can use them to help. Because when we look at OC commands, we can do OC get all -L for label, and I can say app equals Java, and that's going to return basically filter all of the get all and then filter it with label app equals Java. So that's useful, and it's also used by OpenShift itself. So OpenShift uses these labels. There's a number, basically different pieces of portions of OpenShift use labels in different ways, but you'll see that's an important piece. Annotations again are a way of are typically used by OpenShift to help basically manage. So you'll see different components use look for annotations on other objects to kind of decide on what to manage or what to operate on or not. And you'll see that actually we use annotations later in the lab here as part of the service mesh configuration. Other important pieces, the URL. So this is the GitHub URL where it pulled, this is the code where it pulled our source code that shows our hello coming back here, our hello world application. Where did this come, where did hello world come from? Well, it came from, if we look at, copy this, copy that, come over here, look at our, so this is, it pulled down this, the code, and in this case we went to the undertow servlet, so we go in the undertow servlet world, and it pulled this code and integrated that into the container. What did we integrate the code with? Well, we integrated it with our image, and let's see, GitHub URL, image, OC build, so from image, so image stream, we combined it with an image called OpenShift Java 11. All right, so kind of moving on here. Let's see, hello world, we've deployed our basic application, we've looked at some of the components. Viewing the logs, so you can see that we showed that via the web UI. We can also do it at the command line, so we do it OC get PO for OC get pods. What we need is the name of the pod, so we can do OC logs, and then typically do a copy paste, because these these will have 5 random characters at the end of them. So typically, a little bit difficult to type out. So typically copy paste is a good idea. And this is our logs from our application. We come back here, go to back to OpenShift, off by 1, I think. Yeah, here we go. So we go back to logs. It's the same information either way. All right, so interacting with containers. So these containers are Linux containers. They're running, and we can interact with them. We did that via the web UI when we came on our dashboard, back to our terminal. We can do it here, or we can do it at the command line. So we can do it OC RSH and the name of the pod. So I'm now logged into the pod, ps-ef. You can cd around, and you can do, basically you have a shell inside that in the container. You may want to, by default, it's a very, just using sh, so you probably want to switch over to bash, make things a little easier, just to get around, at the command line. If you're used to, most of us are used to a more modern shell at this point, so something you can do. And ID, when we're logged in, you're going to be logged in by default as the user that is running the container. There are ways you could override this. One of the things that's good about OpenShift is that OpenShift, when it runs a container, does not run those containers as root. And in fact, to do so, you've got to actually turn off some security settings to run a container as root. So it's going to run containers using a random UID. In this case, it kind of it picked was it 10025 and then what 5 zeros as the UID for this user. It's going to do that. So each container gets its own separate UID value. And those are randomized and not root. There are ways to interact if you want to log into the container as root. There's ways to do that. So, you know, if you get into advanced troubleshooting, just kind of realize there's ways to, you know, just kind of keep in mind there are ways to interact with the container. And there are ways, you know, even typically this is through OpenShift. There are ways you could even potentially log in to find the node that's running this container, log into the container, and, you know, use your Docker or Podman commands to actually log into that container kind of directly bypassing OpenShift. But really the OCRSH command typically works for most, you know, OpenShift clusters, and is the way you're going to do it, versus more of the Docker, using Docker exec, for example. All right, so we've got this exit. So one of the things, you know, what is, if what happens, you know, if pod goes away, what does OpenShift do? So if we do our OC get PO for OC get pods, oops, well, guess what? I can't do that from inside the container. I need to go back to my regular session here. So OC get pods, and we do an OC delete pod, copy paste. All right. So we look at our pods again. The pod name before was LT86, ended in LT86K. Notice now it ends in PQVLP. And it's been only running 19 seconds. And the reason for that is that, you know, we killed the other pod, the first pod. And so OpenShift recognized that. And because we have a replica set configured, it automatically restarted that container and, you know, spun up, used the container image that was built previously from the build step, and spun up our application again. And if we come back over here and do a refresh of our terminal window, it's still running, right? Hello world is still there. So that's one of the things in OpenShift. That's one of the advantages of OpenShift versus just, you know, running a container at the command lines. OpenShift watches the status of those containers and can restart them for you. Now, making changes, you know, once we have a container deployed, how do we deploy a new copy of it? Well, one, we could delete it, but what if we want to actually make a change to it? So one thing we could do is actually edit the deployment configuration. Let's see here. So OC edit, and if we look back to our steps, it's telling us to go to line 27. Let's see, OC get. It's not quite right. I think it's, yeah, it's actually a couple steps, a couple lines down. We're looking for this. Change that to a 2. Save the file. Notice now we have, this is our PQVLP, and now we have one ending in M8QCH, container creating. The reason it did that is we changed the number of replicas from 1 to 2. So now we have 2 copies of that replica running. And so we do, if we look back at our OC get service, you know, we have one service. So as traffic comes in, it's going to be distributed, you know, as traffic comes in from the route, from the internet to the route, it hits the service because there's a connection between the route and the service. The service is then going to distribute the traffic to these 2 pods, you know, pod A and pod B, basically. Now, the other ways to do that, you can, instead of editing the deployment config, we can scale this. There's commands to scale, basically the number of replicas, so OC scale. So we can do that. I'll just save a little typing, do a little Control C, replica, do OC, oops. OC get PO. So guess what? Container. Now we have 3 copies running, or 1 container running. 9 seconds. Give it a moment or two. You know, give it a second or two, and it'll come up. You can also add. There's a -W option for watch. Of course, now they're all 3 running, but you can do add the -W option to a lot of these commands, and it will look for changes in state. So it'll sit here until and it'll sit just like this until there's a change, and then when there's a change to the running pods in this case, it'll show that new information on the screen. That's handy when you're doing a deployment, you're waiting for something to finish. You can use that W option to you know, keep an eye on what's going on, and so that saves you from, you know, typing over and over again or hitting the up arrow and hitting return, right? So it's all about automation. So let's scale this back to 1. Oh, there we go. It's better. So you saw it was running. I think it's already done, but it terminated. And now if we do OC get PO, we've just got 1 copy. So it would sit there until someone made a change, for example, the number of replicas. All right, so the next step here, so we've deployed our basic Java application. We've looked at you know, deploying it from a application from the catalog. You know, there's a build, so we looked at the build step. an application that does a build. We've looked a little bit at controlling those containers, number of replicas, interacting with them via OC RSH. Now we want to kind of take it a step further and look at, okay, so the last time we used a Git repo that already existed. What happens if we, how do we do it with our code? So in the lab exercise here, that tells you basically go to GitLab or GitHub, basically a public Git repo, sign up, create an account, and then create a repository called Java SDG Workshop. So I'm going to do that now. GitHub, log into my GitHub account. Repositories, create a new repository. Go ahead and, we're doing this as public in a production situation, or, if you have any kind of sensitive code, make it private. We're doing this for the public just to kind of make the exercise go a little bit quicker, but OpenShift does support private repositories. I certainly could configure OpenShift to use credentials to access this repository and make it private and use credentials to access it. That's certainly possible. This time we're just going to do public, just to kind of, keep things moving, because we want to show you the big picture, not get caught up in all the details. But just realize that is certainly, and that would be, again, part of a normal deployment would be a private repo in a lot of cases. So we've got a private repo created. What do we do next here? So did readme. Now basically what we're going to do is we need to put some code in there in this repo. And first we're going to clone it. Git clone. So clone. Come back over here. Copy that link. And what did I do wrong? Did I make it private? Oh, I was not in the right directory. There we go. So I'm not in, I was sitting in root over here, not in my home directory. All right, so clone that directory. Now it's really empty at this point. There's only just a README file, so we need to get some, put some code in that. And there's what we're going to do is we're going to use this this OpenShift quick start code, just really give us, save us from having to type out or develop our application. But really, this is the step where if you're an application developer, you would go off and write your Java code. In our case, what we're going to do though is just use some sample code and kind of push it in there. So what we can do is I've already cloned this OpenShift quick starts repo, so I can just copy that command. And what did I do wrong? Let's see here, OpenShift quick starts. Oh, you know what? I deleted that earlier, so actually I still need to clone it. So we'll go ahead and clone that. Okay. Now I can copy it. When you copy it, make sure to run the copy command as indicated. If you leave off a slash or an asterisk, you'll end up with not the right stuff in this directory. This is what it should look like. I actually did this. I think I got a little hasty with it yesterday and left off an asterisk or something and did not go correctly. So make sure to pick up the full copy command. You want all of the contents of this quick starts directory, all the subdirectories copied over. So we've copied it over. Now we're going to CD into our Java workshop directory. Here we go. CD into that directory. Git config, I've already done these steps. So what we're gonna make some modifications and we're gonna push code back to the Git repo. It's public. We don't have to authenticate ourselves, but Git does require you to set your username, basically your email address and your name, so that when you make that commit, it knows who you are, at least for logging purposes. So if you're doing this exercise from scratch, you'll run the Git config commands. I've already done this. So let's go ahead. What I just need to do is do a Git add. So add all these files. And then I can, so I do a Git status. All right, yeah, new files. So I can do a Git commit -m initial commit. Then I can do a Git push. All right, so what we've done now is we've populated this repository with the sample code. And the reason we've done this is now we can edit this code. We can actually make changes to it. There's other ways we could have forked it. There's different ways to do this, but this is just kind of a lab exercise. But certainly could have also forked that repository and then reference that fork repo later on in the exercise. In this case, though, we're trying to kind of keep it simple and see the big picture. All right, so we pushed it. We've got our basic code there. Now we want to deploy an application, and we're going to use that one. We're going to create a new project to kind of keep things clean. And it is certainly possible to deploy multiple applications to the same project, and that's usually the way it's done. It depends. I say usually. It depends on the user, on the organization. But in the real world, you could deploy every application into one project if you wanted to. In this case, though, deploying it into multiple projects just makes things a little easier to keep track of when we're looking at the status of pods and objects and whatnot. It just keeps it a little cleaner. But certainly, we could deploy multiple apps into the same project if we wanted to. Now, why? Just talk about this for just a second. Why would you or would you not use the same project? Well, if I have the same developer and I'm developer Bob and I'm working on applications A, B, and C, and I'm going to be responsible for those applications, it may make sense to deploy all those applications to one project. However, if you have different developers working on different projects and they don't need to share code, they don't work on each other's applications, what projects allow us to do is to isolate our interaction, basically permissions into the system. So user Bob can have his project, user Mary can have her project, and they can each work on their own applications independently of each other. And that's what we have today. We have multiple people doing a hands-on lab, each independent from one another. However, if you have a team of people, what you typically do, deploy your application, and we'd set up some groups and assign some roles to that group and to those people, so they could the development team could access the applications. So we've got our new project created. Now we want to deploy our application, and we're going to do that. We're going to do that using our Git repo that we just created. So we're going to copy that, come over here, and we're going to pick up that. I think, yeah, it's always going to replicate. Make sure we don't have duplicate HTTPS at the end. So, okay, OC new app. We're going to base it on Java 11. We're going to pull our code from this new repository. You can put the Git on it. It's smart enough to figure it out without it, but you can certainly do .git at the end. And the other piece is we need to add this option, this context directory. So context directory is telling OpenShift that instead of kind of building this application from the top level, basically make the context of the application this subdirectory. So when it deploys this application, everything is going to be set basically from the undertow servlet directory that we looked at earlier. In fact, if we come back here, undertow servlet, it's right here. So this is the context of our application that we're deploying on OpenShift. All right, so we've deployed our application, exposing the service. So in this case, we deployed an application, but because we didn't use a template that had all the pieces defined, we're going to do it more step by step. And in fact, actually, if we do it OC get SVC for service, oops, space out, OC get service. Let's see here, got that service created. We have a service. Oh, we don't have a route. So excuse me. So we did OC get route. So when we deployed the application, it created a service, but it's not exposed to the world. So we need to expose our, it's not reachable from the internet. So now that's the step, right? We need to create that route. And you can do that using the OC expose command. So this is going to create our route. There's quite a few options for this command. You can tell it to, use HTTP or HTTPS ports. One of the common things is tell it which SSL certificates to use. That sort of thing. So you'll want to look more option, in a production situation or developing your app, you would look at the options to that command to make sure it's exposed the way you want, the route's created the way you want it to be. So it's created our URL. So we can copy that, come over here, view our application, hello world. So it's the same thing, I guess, we deployed in the first step. The difference is, though, is we have control of where we're going with this is we have control over the source code, and we can modify that source code and see the results in the in our application. So how do we rebuild it? So, what we want to do is there's a file, the hello world text is actually defined in this file. So if we do here, if we, you can VI or Nano. If you're not a VI expert or, comfortable with VI, use Nano. VI this file here. All right, so this is where that text is actually defined, and we can change that like that. All right, so we changed it, saved it. Now we need to push it into our Git repository. So git add the change. And push it to our repository. Okay, so now we've got our updated code in the repository. We've pushed it. Now, there's different ways, this next step, there are different ways to initiate this, the build operation. In this case, we'll do it manually, production situation or, kind of more real world scenario. You can set up webhooks so that you can set up a trigger so that, if there's a commit made to a Git repo, that it actually triggers OpenShift to rebuild the application using that code. So that's certainly very common to do, in more of a, kind of again, production real world situation. In this case, we'll just kick it off manually though, and we'll start a new build. Now we can do an OC git builds. So this is our first one. So git, we got pending. That was the first one we fired off. And actually we could have done, instead of doing it over again, guess what? We could do the W and that'll watch for that to finish. While this is running, one of the things we can also do here is look at the logs. And of course, this certainly, when things are not going right, this is an important step, but we can look at actually watch the build, right? This is what you see on the screen here is actually the build process. It's rebuilding our application, rebuilding the Java application. It's using that new, the new source code, right? That we pushed to the Git repo just a couple steps ago. It's now actually creating the container images and it's done. So that was and this F option right here was to follow. So that actually followed the logs in real time. And you can use that logs-F with pods as well. If you want to watch log messages being output by a pod, as they come out, you can do that with the -F option. So do our OC git builds. They're both complete. No sense to watch them anymore, but both our builds are complete there. Now verify the change. Let's go back to our web application, and what we should see, hello world from IBM Cloud. So exercise successful. We have shown deploying an application, updating the source code, rebuilding that application, redeploying the container, and we verified that change has been reflected to our users that are accessing it over the internet with their web browser. Take just about a 30-second break before we continue. All right, so we've looked at some of the basics of OpenShift. Now we're going to switch gears and we're kind of increase our complexity and sophistication level and start looking at deploying an application with service mesh. Now, service mesh, I think it's definitely one of the hotter areas in the Kubernetes OpenShift world. And we've seen this, right? We've seen the evolution from containers and Docker to Kubernetes and OpenShift and kind of on top of that, serverless computing, service mesh now. So, we've seen the evolution and certainly, service mesh technology and is something that I think we're going to see more and more of. because it provides gives us advantages when we're deploying these applications with microservices. Gives us visibility into what's happening, the communication between the various components, now there's some good good options out there in the open source world, right, and available from Red Hat that you can use with your application. So deploying an application for service mesh. One thing we're going to do here is create a new project. Again, just to keep things clean. The project, so mjm-employees. Created a new project, and we're going to now deploy a MySQL database using a template. This database will be used by our application. You can just copy paste this. What's it doing? OC process, the OC process command. So it tells OpenShift to take a template and turn that template into a YAML file that can actually be used by the OC create command. So when you run commands like the OC new app, you can use that template directly. However, when you're wanting to change some of the parameters, and in this case, what it's doing is it's taking a template called OpenShift MySQL-ephemeral. It's passing a number of options. It's taking that template, creating an actual a YAML file that can be used for with the OC and piping that to OC create. OC create takes the YAML file and then creates all the objects in that that are output. And in fact, actually, what we can do is we can run just this part of the command. Take off the pipe. So what is that first command actually doing? So instead of piping it to OC create, let's just pipe it to less. Well, this is what it's doing. It's creating, in this case, not YAML, but JSON. You can do -o YAML. Here we go. So here's the YAML version. And it is taking and creating taking our template and combining that with the parameters, the passwords, for example. Then we look at the options that we're feeding in. We're setting the username, setting the password, that kind of thing, right? And then so this is this YAML is being fed into the OC create command, which is being told to look at standard in for the YAML file or the object to create a definition. So let's go ahead and run it for real. OC create. So what did it do? It created a secret, a service, and a deployment fig. And if we do an OC get PO, it should be creating our MySQL container. This is the first container is what we call a deployment container. It's used to spin up the actual application container. We'll have to use our W option. Well, of course, now they're both running again, so we're in good shape. MySQL is up and running. So once you have a database running, what we need to do now is we'll do some configuration of that database. So there's different ways to do that, but probably the most straightforward way here today is to simply connect to this database, the RSH command, bash, just in case, not really necessary, but just in case we need to do something, multiple step. We're going to run the MySQL command, tell it the root user. So now we're logged into MySQL, and we're going to grab all of this. So first I'm going to say use employee, database change, copy that in, and then quit. So exit out of MySQL, and then now exit out of the OCRSH. So I'm back at my base login to the Bastion node. So we've done configured a database. Now we can deploy our application. And we can do that. We're going to use a Spring Boot application as an example. So we're going to run OC new app. We're going to tell it OC new app. That's a really cool command. OC new app can use a combination of basically you can tell it an image and source code, put the two together. It supports multiple build types, so you can start from different points. It will also guess. So one of the things that's pretty cool is it'll actually, it does a pretty good job too. It'll kind of look at your source code and say, is this a Java application or a Python application or a Ruby application? And it can actually combine that with an appropriate base runtime image. So it created, looked like that worked. Notice it did not, one thing it's saying is that it did not expose the application. So application is not exposed, in other words, there's no route. But if we want to do that, we can run OC expose and expose that service. I guess that's actually what we want to do in our next command here. So it's going to create our route so that we can actually access the application. All right, and before we go on, we need to make sure this is actually working. And the first step would be to get the URL for the route. So let's do an OC get routes. This is our very long URL. So copy that, curl. Oops. There we go. Okay, so now it's working here, but I was not spun up all the way. So the main thing is Kenny. So we wanted to see this consultant as the output we wanted to see. Clear. So what we're doing is we're calling our application and we're passing it passing it basically a command or an API call to say, okay, check title. What's Kenny's title? Kenny is a consultant. So that's showing us that the application, our little test application, is working. All right, so we have a basic test application. Now what we want to do is instrument this application. And to do that, we're going to basically connect this application in with the service mesh operator, which is already deployed on this OpenShift cluster. So there's some basic, when you're kind of starting at the very beginning, you deploy an OpenShift cluster. There's then some steps that the cluster administrator would do to deploy these, the basic operators. Once the operators are deployed, let me show you, actually kind of, instead of just talking to it, let's actually look at it. Come over here. So we look at installed operators. So these 4 operators would be installed by the cluster administrator. Once they're installed, we can now reuse these installed operators with our application, or as you're deploying applications, and you'll see that everyone doing the hands-on exercise with this cluster is going to be basically kind of using these installed operators and configuring, connecting them to their application. So going back to the lab instructions here, so first thing it tells us to do is create a new project. So OC new project. And there is, by the way, I don't have it set up. There is a command, OC has a command line completion. I don't have it set up in this this particular shell, but that's very handy. So you can do OC new and then hit the tab key. It'll help you complete your commands. So that comes in handy, especially if you're new to OpenShift. So OC new project, MJM service mesh. That's what I want to do. Okay, so I've got a new project. There's nothing in that project. It's basically empty. So now it's telling us to go to the OpenShift web console. Let's close some of these things we're not using. Not using that right now. All right, so OpenShift console. All right. So navigate to initial service mesh project. So this is, if you're using the OpenShift web console, one of the things to keep in mind is this project selector here. This sets the context for what you're looking at. So what we want to do is change this to MJM service mesh. So if we look back here, for example, pods, now that pods is set to MJM service mesh, there's nothing deployed there, so there's no pods. If I change this to, for example, one of the, I don't know, Java template, we'll see the pods. That was one of the deployed from the earlier exercises. So make sure the project is set correctly to the context. That can create some issues if you kind of not watching what you're doing there. And then what did I do? OC, I saw one. Actually, I've got to go through and clean up some of my projects. MJM new app. Yes, some of these I could go through and delete, but we'll do that later. So MJM service mesh. All right, so we've got that there. It's telling us to click on go to operators, installed operators, and then and basically then go to service, the actual service mesh. So installed operators, Red Hat OpenShift service mesh. And one of the things we're going to need to do is we're going to need to deploy some of the basically instances for our app in this for our project and for our application. You know, we could have multiple, and we'll have multiple instances running of for example, the control plane on this same cluster, each tied to a particular application. So what we want to do is create an instance, make sure we don't miss any steps here. And so service mesh, so click open a service mesh under provided APIs, create instance, which is where we're at. Now it's saying service mesh control plane API, accept the defaults for the base, video basically accept the defaults for a basic install and click create. So go down here, that's our default. So I'm gonna go ahead and click create. So this is deploying a ITSO control plane instance within this MJM service mesh project. All right, so we've done that, control plane install. So we want to check as this deploys a number of pods. So we want to make sure that everything is working, and we can do OC get PO back here. Notice that we now have some pods spinning up. Watch those as they're deployed. Pods there. All right, so we've got our pods up and running. Now we need to add our project to the service mesh. So we're kind of, again, kind of continuing on, but tying this particular instance of service mesh control plane to the project that we're actually using, that we just set up with MySQL, and that we're going to have our application working. Notice actually, we still have some more. Okay, deploying Grafana. So actually give it a minute or two more to finish this deployment. All right, we should be able to continue. I think it's got all the pieces. Grafana, Cali. It takes it a few minutes to spin everything up. So next thing we need to is basically going back to the same area here, but we want to go to Service Mesh Member Role API. So we come back over here, Member Role API, create an instance. And this is something important that we get this right. If you don't get this right, this exercise will not work. So what we want to do is set this to the project that we created earlier. And if we just click the drop down, I'm not actually going to change anything, but no, MJM-employees, that's what we used earlier. So members, MJM employees, you could list multiple members here if that makes sense for your application. Here though, we're just going to have the one member. So let's go ahead and create. All right, so we've done that. So next thing we want to do is look at basically, okay, it deployed a bunch of stuff. How do we access these applications? Right? What did it actually do? And I noticed, I think as a good old Google Docs gets us sometimes, it messes up the quote marks. So let me fix this actually. Fix this for the next person that comes behind. So, okay. So now with actual single quotes, OC get routes. Okay, here's the route. So when we deployed our control plane instance, it set up in addition to the base service mesh framework, it created instances of our monitoring applications that are going to allow us, give us visibility into what the service mesh is doing. So Grafana, Jaeger, Kali, and Prometheus. So each of these is a route, and so copy each of these in turn. They are exposed. You want to do HTTPS. Now we can log in with OpenShift. Notice that the application is tied into OpenShift authentication, which is tied into IBM Cloud IAM authentication. So notice it's not going to should not ask me for a password or anything like that, as long as I've, with this setup, access, as long as you're tying into OpenShift OAuth, it's going to give us a single sign-on capability, which is actually really nice. Let's see here. So we've got that. We'll go ahead. Let me just go ahead and open each one of these. Oops. In turn, so we'll have them open. Let's see. There we go. Log in. And Prometheus. So the first time you access some of these applications is going to ask you, as far as permissions, you'll want to make sure those are both checked. Allow selected, click allow selected permissions. Yep, so we've got our tools up here. We've got our Grafana dashboard. We've got Jaeger for tracing, Kali here, and Prometheus, which is alerting and monitoring. So let's come back here to our instructions. We've got basically the basic infrastructure in place now, but we don't have everything tied together. We've got a couple more steps to do. So what we want to do here is, one of the things we do is basically instrument our application. We want to actually connect our application, and we're going to do that by using what's called a sidecar approach. And a sidecar, this gets back to the idea of running multiple containers within the same pod, and that's going to allow us to basically connect our application with Kali, and for that data to for Kali to have a visibility into our application. So the way we can do that is by editing the deployment configuration. Now, got to watch out, where is that deployment config? Well, it's in the MJM-employees project. So we do OC project and employees. We do OC get DC. Oops, OC get DC deployment config. So it's telling us to edit this deployment config. If you don't want to, you don't have to change projects if you don't want to. I did it just to make things a little easier. But you can also do this. I can do OC edit deployment config. Oops, not all that. And then I can say -n, which namespace. So instead of changing namespaces and then editing, you can also do this -n and the name of the namespace. And this works for editing, getting all the OC commands. You can put the -n and then name of the specify a namespace. That's actually a very good habit to get into. That way, if you're mistaken, like creating something and you're not in the right project when you run the command, that can cause bad things to happen, or things you didn't intend. Let's put it that way. So I especially need any kind of formal documentation. We'll try to production documentation. Go ahead and add the -n option just to make sure there's no ambiguity as far as where the edit should be done, or the creation or deletion, or whatever that command is, to specify which namespace or project that's going to occur in. So OC edit deployment config Spring Boot demo in the MJM employees namespace or project. Opens up an editor, and it's telling us that we need to add in this annotation. So I'll copy that. Now you have to be careful that the labels, there's actually a couple of different annotations. There's one at the top here. What we really need to do, you have to add it. Oops. Yeah. Insert, paste. Let's do that again. Let's see here. Control C. Yeah, there we go. Now, make sure these are really double quotes. I think they are. One thing that's very important with YAML is that you indent with spaces and that you keep everything lined up. If this sidecar, if I did not have it lined up with OpenShift, it would not work. And actually, when I went to, you would actually receive an error message when you save the file, and it would not be able to apply that change to the deployment configuration. So that's probably, if you're new to OpenShift, dealing with YAML is probably one of the harder things to, makes the learning curve a bit steep. Once you understand YAML and kind of understand how it works, it's easy to use, but it's not really, I don't know, but intuitive. I guess depends on how you're wired. But you know, with YAML, spacing, that indentation really makes a difference. Completely changes the meaning of the data, whether things are lists or dictionaries, and all that. So you got to keep your indentation correct, and you've got to, you know, spaces, not tabs. So we've added our sidecar here. And let's see here, go ahead and now notice that when I save that, yeah, so we have a container creating. So one of the things OpenShift, when you edit a deployment configuration, depending on what you edit, OpenShift will automatically redeploy that application, that deployment, using the new using the new version that you saved. So it's actually redeploying the demo application. In this case now, we're on demo-2. This dash here, -1, -2, this is basically the tells us our instance, you know, how many times this has been run or started. So it was the first rollout. This is the second rollout. And now we have our application, our pod running. So we can do an OC describe PO pod name. All right, so we've got our labels here, container ID, and what we want to look at, this is the important part here, this sidecar, right? This is I'm verifying that it deployed correctly. If I had not done the annotation correctly, basically there would be all this ITSO stuff was not there by default. In fact, we can see that if we should be able to OC get PO. If we look at the older version, OC get PO, oops, OC describe. Let's do deploy. No, it's gone actually. So never mind. So so we added the annotation, confirmed that the sidecar is listed, and I apologize I didn't show you before I changed it. But you know, if we look at another application, you know, MySQL, for example, what you'll see. Let's look at MySQL. So we look here. I don't know, just, you know, it's kind of hard to read. Obviously, text on the screen. There's nothing about ITSO and all this, right? There's nothing about sidecars, nothing about ITSO, and then that was the same with Spring Boot demo until I made that update. So once you do that, save it. OpenShift detects the change in the deployment config, redeploys a new pod, retires the old, spins up a new pod, retires the old pod, and then with that new configuration. So the next thing we're going to do is we're going to deploy applications so we can basically give us ability so we can some traffic to watch. So we're going to use the OC create command, and we're going to pull some YAML off of a Git repo. So just a simple matter of doing a copy paste. Make sure, one thing I've noticed working, you know, it's easy when you're especially doing this copy paste bit, you know, you're following someone else's directions. It's easier just to copy it in, hit enter, and go on to the next thing without really watching what the previous command did. So it's very important actually to make sure that, you know, did this actually work correctly? Did it actually create, you know, are there error messages, that kind of thing? So in this case, everything worked fine, but you want to pay attention to that as you're going through this or any exercise. You know, did the command actually work the way it was supposed to, as intended? You know, things like, you know, there can be instead of a single quote, it can be a a copy paste problem because of the wrong kind of quote. Maybe you didn't grab all the characters, you missed a line. All kinds of reasons things can go wrong. And so if you don't see that at the time and you get 2 or 3 steps down later in the process, it can become difficult to kind of unpack and figure out what's actually going on with your application, what's going wrong with it. All right, so we've got our application deployed. We've got a script here that we're going to use to provide some traffic to our application, which will in turn give us something to look at in the service mesh and these dashboards. So there's on the Bastion host, there's under user local bin, there's a file called traffictest.sh. That shell script, you need to copy that into your home directory and actually just take a look at it. What I did with it, so if we cat, it's a simple shell script, cat traffic, simple shell script. The default one, this line is actually uncommented. It just says export control plane project equals empty, with nothing set. So you're going to have to copy that. If you just try to use the one in user local bin, it's not going to work correctly because it overrides this. And even if you set it in the environment variable, it kind of gets unset by the script. So instead, what I do is I copy the command. What I did was, I did a copy user local bin traffic into my home directory, created a bin directory like that, copied it here. I then edited the file. And actually what I did is I commented that out. What that allows us to do is now I can just set control plane project at the command line and not actually have to edit the file each time. So let's see here. What I need to do is export control plane project equals MJM service mesh. That looks correct. And now, and to show you, by the way, the default version, this is probably something we'll need to improve the next time through. Traffic. Yeah, so the default one just has this. So you'll actually, this file won't work as is. You'll have to copy it and edit the file in your home directory. So I've got it set up though, so it should work now. It should be able to run /traffic. There we go. So now this is generating traffic and it's just doing queries. Remember when we looked a few minutes ago now, we spun up that MySQL database and we put some records in that database. If we come back here, if we look at what that MySQL database command did, yeah, so insert into default Darren CEO, Mike's an admin, Kenny's a consultant. Right, and now it's just hitting our application and querying the values or the status of these users. So we've got that done. Observe the graph. So now we should be able to go back here and we've got our telemetry running. We've got, and we'll look into this in a little bit more detail. The main thing is just kind of this point, making sure we've got some activity, everything's healthy. We should be good to go here. If we go back, let's come back over to Grafana. Let's pick a dashboard. Let's look at. Yeah, here we go. So we got some data transfer showing up now, bytes transferred per second. This is giving visibility, some components. There's not a lot going on here, right? We're just doing simple queries against 3 values, right, in a MySQL database. But this is showing that the service mesh, we're able to pull metrics out of our application. We come here, so Grafana is working as intended. If we have to refresh this page. Yeah, so now we have our select our service and find traces. So now we have visibility into our traces. We're actually able to see now how long it's taking each step. This application, of course, is purposely designed, microservices based, right, to fit with this exercise. And via the ITSO and Jaeger, we're now able to see, how long these requests are taking and at each step. So instead, before, your application, if something was running slow, it's very difficult to figure out, okay, which of these 4 steps is actually adding, taking the most time, right? Or taking longer than you expected. With this stack and service mesh, you have visibility into what's taking the longest or the shortest time. It allows you to really kind of see under the covers what your application, a microservices based application, is doing and how it's behaving, and help troubleshoot problems, and establish, even if your application's working great, and you can establish a baseline. Then if something changes, things get bad, go bad or get worse in the future, gives you the ability to do troubleshooting. Or maybe you just say, hey, we've got more users coming on board. Let's say we know this particular API call that 10 milliseconds is our max. All right, well, how do we improve it? How do we make sure, how do we add more user to our user base, support more users while still keeping under 10 milliseconds? So we might then drill down and kind of figure out, use these tools to help us uncover what our application is really doing behind the scenes, how those microservices are, which are behaving, performing, and which are not. So we've got that there. We've got, back to Cali, telemetry. Let's change this to employees. There we go. So here is our, we should be able to zoom in a bit. So there's our candidate that we're seeing, incoming, you don't have any outgoing traffic, requests. And then Prometheus, let's see here. I'll have to get a valid search query here. Yeah, not a big Prometheus expert. Yeah. All right, I'll have to come back to that one. All right, so we've got Cali, Jaeger. It's still running. Our application is running, serving queries. And yeah, I think we've got our basically successful deployment at this step. And you see here that Grafana is showing us activity, our virtual CPUs, memory, and so on. We can look at these dashboards. Let's see here, service dashboard, client requests, volume. So visibility into our application and how it's performing. Well, if I could switch back over, for some reason I can't quite switch back to the tab. There we go. Let's see here. So other observability tools, traces. Yeah, so that's the applet. That is the demo. How you run kind of from beginning to end. One thing I want to make sure that if there are any questions, I guess a couple things here right before we wrap up. One, any questions, be happy to chat about them. Either you can send them in the Zoom chat. We also have some time here. You can probably just talk it through as well. One thing is it'd be really appreciated if you can complete the survey. It's very important. That feedback is very important to Red Hat and Stone Door Group. So we really appreciate you taking just a couple minutes to complete the survey. Oh, there it is. Okay, so yeah, it should be popped up in your Zoom meeting now. So if you take a couple minutes, I think there's like about maybe half a dozen, 4 or 5 questions. All right, so excuse me, 10 questions, but very straightforward. Take a couple minutes to answer that. We'd really appreciate it. And this introduction to service mesh and OpenShift. So kind of to recap what we've shown is one, this is an introduction to OpenShift. It's a huge topic. This is people spend 40 hours a week, 52 weeks a year working on OpenShift, and probably more than that, right? So and even that, you could do that for years and not know everything about every piece of OpenShift. So this is just scratching the surface, but we wanted to show you what's possible. And what we showed is, first of all, deployment of OpenShift in IBM Cloud. Showed accessing that integration with IBM Cloud IAM. That integrated single sign-on, visibility to the OpenShift cluster itself. We showed you kind of the basic application deployment on OpenShift using OC new app, OC new project, OC new app. We showed you deploying an application based on a template. We then turned that and actually kind of went sophisticated and say, okay, let's not deploy just a generic app. Let's do one with our code. And so we created a GitHub repo, deployed an application using some baseline code, made a modification to that code, and saw it redeploy on the cluster. We then spun up a multi-piece application with a MySQL database backend, added some records to that database, deployed a Spring Boot application, and then instrumented that with the service mesh, using the service mesh operators, and then created a load on that application, and to give us, give some data to look at in the UI. All right, well, great. Well, thank you on behalf of Stone Door Group. I'll stay on here a few minutes. If anyone has any questions, I'm going to stop sharing here. And I really appreciate it. Thank you, everyone. Stay safe. Have a great week. And again, I'll be here for a bit if you have any questions.